Hi everyone, today I'm going to be talking to you about ratios of scale drawings, which the title of can sound kind of confusing, but you probably already know a little bit about what I'm going to say. So here are some examples of ratios of scale drawings. This triangle is a bigger triangle that is represented by this smaller triangle. If this smaller triangle was made bigger, it would be exactly the same as this triangle because the smaller triangle was made to scale of this bigger triangle. You use scale drawings to represent a bigger shape or object with a smaller shape. A real-life example of the use of scale drawings is blueprints for like houses or construction. You can't write down or create a shape of the real size of the house because that would not fit on a piece of paper. So what you have to do is you have to scale everything down and use those measurements to create the scale drawing of the building. And then the measurements on the scale drawing will be exact so that all of the measurements on the real building will work out together. Here are some more examples of scale drawings. This smaller rectangle, if you take each of the sides and multiply it by 2, this would be the scale factor in the situation. Take each side multiplied by 2, then you get this rectangle. And then if you take this triangle and multiply all the sides by 3, you get this triangle. Here's an example of a scale drawing. So let's say you have this triangle with 18 centimeter side, 6 centimeter side, and 12 centimeter side, and you want to make a smaller version of that same triangle. So what you would do is pick a scale factor. In this situation, I picked that 6 centimeters would be represented by 1 centimeter. And then you use that scale factor to figure out what each of the lengths on the smaller triangle will be. So this side is 6 centimeters, and we said that 6 centimeters is represented by 1 centimeter. So this side would be 1 centimeter on the smaller triangle. This side is 12 centimeters, and that is like 6 centimeters twice. So that would mean that the representation side would be 1 centimeter twice, which is 2 centimeters. And then this last side is 18 centimeters, which is 6 centimeters 3 times. So that would mean that this side is 1 centimeter 3 times, which is 3 centimeters. In a scale drawing, everything is proportional. So you can use proportions to figure out what the length of the sides of your scaled object will be, or you can find the side of a original object from your scale drawing with the scale factor that you chose. So if a scale drawing of this shape is created with a scale factor of 1 inch equals 10 feet, what would the lengths of the sides of the scale drawing be? So this rectangle has one side that is 45 feet long and another side that is 10 feet long. And we are going to create a scale drawing of it using the scale of 1 inch equals 10 feet. To figure out what each of the sides would be, I set up a proportion. So here I have 10 feet over 1 inch, which is our scale factor, is equal to 45 feet over x inches. So right now I'm finding the length of this side. And then when you have a proportion, what you do is you cross multiply. So I'm going to multiply 45 by 1 and make that equal to 10 times x. So then you have this equation. And then you divide each side by 10 and you get 4.5 inches equals x. So with this scale factor, the 45 feet can be represented by 4.5 inches. And then we have 10 feet on this side, which in the scale factor says that 10 feet is represented by 1 inch, so this last side will just be 1 inch long. If the scale for this drawing is 0.5 centimeters is equal to 5 meters, what is the actual length of the unknown wall? So in this practice, we're finding this length of the office building if this is a scale drawing and it says that the wall here is 4 centimeters long. So I'm going to set up a proportion again. So here we have 0.5 centimeters over 5 meters, which is our scale factor, is equal to 4 centimeters by x meters. And when you're setting up a proportion, you want to make sure that the same label is on top and the same label is on bottom. So on top I have centimeters on both sides, and on bottom I have meters on both sides. And then I'm going to cross multiply, so I have 4 times 5 is equal to 0.5 times x, which will give me 20 is equal to 0.5x. And then if I divide each side by 0.5, I get x equals 40 meters. So the actual length of this wall of the office building will be 40 meters. A scale on a map shows that 2.5 centimeters represents 15 kilometers. What number of actual kilometers are represented by 17.5 centimeters on the map? So we're going to set up a proportion again. We have 2.5 centimeters over 15 kilometers is equal to 17.5 centimeters over x kilometers. So we have our scale factor here, and then we have our known length here, and then our unknown length here. So we're going to cross multiply, which will give us 17.5 times 15 is equal to 2.5 times x, and that gives us 262.5 is equal to 2.5x, and then we divide each side by 2.5, which will give us 105 kilometers. So remember that scale drawings are used to represent a bigger shape or object, and that proportions are used to find the correct scaled values. And when you're making a proportion, you want to make sure that the same label is on the top and the same label is on the bottom. Your scale factor will be one of the proportions, or if you're trying to figure out your scale factor, that can be an unknown. But you'll have your scale factor as one of the proportions, and then on the other side you'll have your known value and then your unknown value, which you'll be trying to figure out. And then you cross multiply and then solve for x.